Hi, welcome back to the next video on Chapter 5, Steam. We are almost done because we went through the introduction to Steam, go through how to draw the phase diagram, talk to you about the Johannes fraction equations as well as knowing how to interpolate between values, okay, knowing that the Steam table actually does not produce all the values that you need. Sometimes it is in between the values and you have to do interpolation. There's one more thing that I like to say also is that phase diagram, okay, the state of the steam, okay, can be determined if only two variables are provided to you. For example, if I give you pressure and temperature, you should be able to know roughly which region that state is at. Okay, is it superheated? Is it wet steam? Is it subcool? You should know. Okay, if I give you volume and temperature, or if I give you pressure and volume, then you should be able to tell me which region does it belong to. Only when you know which region it belongs to, then you can fully make use of the steam table, which section of the booklet. Alright, so let's say, for example, so what we have here is the state at 5 bars and 160 degrees Celsius. So which region do you think it belongs to? So straight away you can actually go to 5 bars. Okay, and you will see this column of numbers. Alright. Okay, you will see this column of numbers. 5 bars. Okay, you have your pressure, boiling temperature, Vg, U, and H. So if we want to plot, right? So if I draw PV diagram at 5 bars, okay, let's say this value is at 5. So this means that at 5 bar, this isothermal line, this constant temperature line will be its boiling point. And what will this value be? If you look at 5 bar, right, its value, the saturation temperature will be 151.8. So this line is actually 151.8. So since at 5 bar, the water boils at 151.8, if your state is at 160 degrees Celsius, then it should be at superheated region. Okay, so the way to show this is you need to draw the 160 degrees Celsius line, which will be higher than 151.8. So there's another isothermal at 160, and you know that it is at 5 bar, right? So 5 bar 160, it should be this location. Okay, so it's on the right side of the hill, thus it is superheated. Okay, the next one, let's say if you are given 130 degrees and volume 0.54 meter cube per kilogram. Okay, how do I see? Well, you can go along the saturated water and steam page 4. Okay, and you will see that actually there is a saturation temperature of 130 over here, and it is at 2.7 bar that the water will boil at 130. Okay, so you can see that you can imagine your pressure volume, okay, and it is boiling 130 degrees Celsius. Okay, at what pressure is this? 2.7 bar. So since the state is at 130 and the volume is 0.54, you will see that the Vg is 0.6686. Alright, so actually this point is 0.6686. So where do you think this value is? This value is less than the Vg. So definitely it is less, okay, and thus it is under the hill. So it should be following 130 and at a value lower. So this is your 0.54. Okay, So the answer is that this particular state is at wet steam. Okay. So again, I like to stress, if any two variables are given to you, you should know which region your state is at. Okay. And I have another very practical problem to highlight to you. So for example, the question goes like this. So let's say it starts from 9 bar at 200 degrees Celsius, and then it undergoes a constant volume change. Okay, it drops to 5 bars. Then you need to know where is the state. Okay. So just now I said any two variables you should know the location, right? So then you look at state 2, only one variable. Actually, that is not true because you also know the volume. Okay, so first thing is to identify where is 9 bar 200. If you go to 9 bar, okay, you will see that the water ball is at 175.4. So at 200, right, it will be superheated. So you can illustrate this using this. So this is 9 bar, okay, and this is 175.4 degrees Celsius. So at 200, it should be a higher isotherm, 200 degrees Celsius. So 9 bar 200 is here. So the starting is here. Okay. And then it's supposed to go down constant volume. So constant volume, which means the volume does not change. It goes down vertically because your pressure drops. Okay, drops to 5 bar. So somewhere at 5 bar, right? Let's say, let's just draw first. Draw a constant volume. And this volume you can actually find. Okay, and it drops to 5 bar. So there are two scenarios. Okay, let me try to draw this to you. So one scenario is this is 5 bar, and because this is constant temperature, it will drop here, and it will drop inside the hill, so it becomes a wet steam. However, you won't know if that is the case because there's also another scenario whereby I'm going to draw the same thing. This is 9 bar. This is 200. Let me try. Yeah, okay. So 9 bar 200, it starts from here. And maybe it will just go down to hit 5 bar. But it will still remain out of the hill. So it will still be superheated. So which case is which? This is up for you. This you should need to know how to find. Okay. So let's find this volume first. Okay. So since it's 9 bar 200, you are able to go to the superheated table and find yourself that the volume is 0.2305. Okay. So this volume is actually 0.2305, which means as it drops down to 5 bar, it will still be 0.2305. Now, then the question is this. So I have pressure 5 bar and the volume now I know is 0.2305. Alright. What should I need to find out next? If you just mainly look at 5 bars, okay, you actually have the VG. Okay, VG means at 5 bar, my VG is 0.3748. Means 5 bar VG is this location. This location is 0.3748. Okay. So what I'm trying to say here is that you will find out that the volume at this point, at this state, is less than the VG at 5 bar, which is 0.3748. Okay, you see? So it means that the state is having a volume that is less than this G line. Okay, as long as the G line volume is higher, means your state is under the hill. Okay, if the case is such that your volume, your volume here, right, is actually more than this Vg, your volume is more than this Vg at 5 bar, then you will tell yourself that it is at the superheated state. Okay, so this is the thing to compare with. You compare the current volume at that state with the Vg at that pressure. Okay, so yeah, so this is the way to determine whether it is under the hill or out of the hill. Okay, superheated.